Now we're going to talk about function. I'm going to talk about function. So let's start with the definition of function. As you can see, function definition is like this. Let x, y be two non-empty set. Whatever that means, right? Whatever that means. Well, it basically looks like this. Now you have set that's called x, and you have another set that's called y, and has to be non-empty set, meaning you have to have something inside. Let's just say a, b, c that you have, or 1, 2, 3 that you have in y, right? A function from x into y, so I guess the direction is from x to y, is a relation that associates with each element of x exactly one element of y. Meaning like this, there should be a relation between x and y, but there must be one line coming from each element of x. There must be one line coming from each element of x. So, for example, a goes to a, b goes to 2, c also goes to 2. Now, this describe function x into y. Well, yes, because there's only one line coming from each element of x. I mean, would it be a problem because both b and c goes to same 2? Well, that's not a problem because one line coming from each element of x. So let's say, let's check out a couple of examples. Let's say, well, let me change color. Example, say function or not. Let's say first one. Say you have set of x, set of y, say 1, 2, 3, a, b, c, right? And let's say 1 goes to b, 2 goes to a, and 3 goes to c. Now, is this describing function? Well, the thing that we should check is one line coming from x. Each element of x, only one line. Yes. So this is yes function. All right. Next one, let's say you have group set x and set y. Let's say 1, 2, 3, 4, 5, 6. So it doesn't have to be A, B, C, 1, 2, 3. You can just make up your own. Let's say 1 goes to 4, 2 goes to 5, but 2 goes to 6, and 3 goes to 6. Now, is this describe a function? Answer is no, of course not. Why not? Because of these 2. There are 2 lines coming from x, right? One element of x. So if that's the case, this is not going to be a function anymore. Well, think of this x as, group of boys, and think of this y as a group of girls, for example. Let's say boy number 1 likes girl number B, boy number 2 likes girl number A, boy number 3 likes girl number C. No problem. Everything's fine. What about this? This boy number 2 likes girl number 5 and likes girl number 6 at the same time, which is no good, right? So if it has to be a function, there must be one line coming from each element of x. All right, on the more serious note, let's try another example. Let's say determine if the following equation define y as function of x. All right, so let's say first equation, y equal to x plus 1. So what we should check is each different value of x will produce only one y. Let me repeat that again. We should check whether each different value of x will produce only one y. If that's the case, then it's a function. So, for example, let's say when x equals 1, if we replace this x by 1, 2 times 1 is 2 plus 1 is 3. Y must be 3. When x equals 1, can we have any other y value besides 3? No. As you can see, it's not possible. You can only have one y. If that's the case, this is function. Right? Counter example. Let's say x squared plus y squared equal 1. Let's check out this equation. So, in order to see this slightly better, let's rewrite this as like this: y squared equal 1 minus x squared. So what we did, we moved this x squared to the other side, and we have this. So I want to get rid of this square, so what we are going to do, we're going to take the square root on both sides. So I'm going to take the square root, y squared equal square root 1 minus x squared. Now, what happens to the square root and square? Now, if you remember what this square root means, square root means, let's say you have x there, x to the what power? Half power. So whatever that you have inside, let's say x, square root means is to the half power. So let's look at here. What does that mean? That means y square to the what power? Half power. So what happened to this exponent and this exponent? What do we do with this? We multiply them together, right? We have exponent over exponent. We multiply them together, and that becomes just y, right? So this left-hand side is just going to be y. Now, one more important thing that we just didn't mention yet. See this part right here? Whenever that we take square root on both sides, we must have plus or minus, right? We must have this plus or minus. So whenever we take the square root on both sides, we must have this plus and minus. So that becomes this. What about this? Well, there's nothing to cancel, so it'll be 1 minus x squared. Well, some of you might wondering, why didn't we cancel this square root? Because we have square there. Well, we cannot just cancel it like that, because that square only apply for this x, not to the whole term. If it was for the whole term, then we would have canceled the square and the square root. But this square is only for the x, so we cannot cancel this. So we have these two. So what does that supposed to mean right here? Well, for one particular x value, we will have a plus case and the minus case. For example, let's test, let x equal 0, for example. If x equals 0, what's y going to be? Y is going to be plus minus square root of 1 minus 0 square, which is just 1. What's square root of 1? Well, that's plus minus. Um, that's 1. Square root of 1 is just 1. So y is going to be plus minus 1, right? So what does that mean? When x equals 0, this goes to y equal 1, but this also goes to y equal negative 1. The two line coming out from 1x value. So this is not a function. Right? This is not a function. Okay.